answer. Approximated means we can provide one-way guarantee. Either we can prove the property or we can violate the property. So first we will go into the proving the property, which we also call soundness, which means if with our algorithm, if we can say property is verified, then it should also verify on the original query. For example, here suppose this is the ReLU activation function, right? And it can be basically shown by this graph, right? Which is basically 0 if x is negative, and y will be same as x if x is positive, right? Which is nothing but y is equal to max of 0 comma x, right? So we have seen how we can encode this into a MILP solver by using for each ReLU variable we required one binary variable. Binary in the sense integer variable which can take value 0 or 1, right? So if there are let's say 100 ReLU activation in a neural network, then the problem become 2 to power 100 kind of complexity, time complexity. So one way to basically, and why it is becoming like this, because of this choice, right? We have this choice. If x is less than equal to 0, then y will be 0, right? Or if x is greater than 0, then y will be x, right? So this or is creating a choice, right? Is there a way we can remove this choice from the ReLU function? And yes, there are ways. For example, here we can create a triangle by merging this these 2 points, and this become our upper constraints, this two become our lower constraints, right? So suppose upper constraint says some constraint, let's say in this form, y is less than equal to mx plus c, right? And since we know these 2 points, we can easily compute the equation of this line. And lower expression has the constraint something like this: y is greater than equal to 0 and y is greater than equal to x, right? So these constraints basically represent the area of this triangle. Now before we have the function only these two lines, right? This line and this line. We have whole triangle, so all the point in this triangle are nothing but some spurious point. Spurious point means some extra noise we have created, but at the same time we have removed the noise, we have removed the choice from the ReLU activation function, right? So since the choice is removed, now we don't need any binary variable, and we can encode it as an LP problem and just verify the neural network. The condition is if the property is verified, then we can say a property is really verified. If it doesn't verify it, then we can't say, because the counterexample might occur because of this extra noise, or it may occur originally. We can't say anything, right? Now we also have seen deep poly. Deep poly basically capture one upper and one lower constraints. For example, here we had one upper constraint and two lower constraints, these two lower constraints, right? So deep poly doesn't call any LP solver or MILP solver, but it maintain either one upper constraint or one lower constraints, right? So there are two choice of lower constraint. Either it can be this. In that case, this will be our triangle, right? Or it can be this. In that case, this will be our triangle, right? And it choose either of the two triangle dynamically, whichever has the less area. For example, in some cases, this may have the less area, and in some cases, it may have a less area, right? So less area means what? Less noise we are adding in the over approximation, right? Similarly, we also produce some abstraction for sigmoid, 10H, max pool kind of function, which is mentioned in deep poly. So in the last class, we explained for sigmoid, but for 10H is also have the similar abstraction. Abstraction means what? We have one upper linear constraint and one lower linear constraints, right? And similarly for max pool. So this is what we have seen in last 2-3
I
classes.
mean, I have one question here. For the lower
Yeah,
constraints, you showed
yeah,
the encoding for the upper constraint. For the lower constraints, I guess you will have to encode multiple lines. There was one line was good enough. I mean, and y is greater than or equal to x. But here
yeah.
you have to have other lines also encoded. I mean, as linear constraints, correct? Yeah.
Mm, other lines means sorry.
No. See, my question is, what is the encoding as linear constraints?
Yeah, yeah,
There you will have to, there'll be other lines that you will have to have expressions for inequality.
yeah, yeah.
Yeah,
Here,
that's what I'm clarifying. That's
yeah.
all. Okay.
So
And
yeah, so
uh,
the thing is, we can also call LP solver in these two cases also, right?
mm,
But the thing is, I mean, deep poly is I mean, whenever we call solvers, they somehow create some complexities. But deep poly avoid the solvers at all, and they just maintain lower and upper constraint for each neuron, and finally try to verify the property directly without calling any solver.
mm. So it
Yeah,
dynamically chooses in some ways some kind of heuristics to choose between. It maintains that and then
yeah,
propagates
yeah.
using that.
Yeah. So here basically we have two choice of abstraction, either this one or this one. So dynamically, deep poly compute the area of both triangle and
Mm,
choose the one which basically has the less area.
okay. Mm,
Yeah, less area means less noise.
mm.
Right. So what basically abstraction do in general, right?
Yeah.
Suppose,
Any questions here? This is just Afzal gave a summary of what he had discussed so far. Any questions from the class? Okay, go ahead.
yeah, yeah. So what over approximation does? For example, let us try to understand it by basically pictorially. So let's say this is some set of constraints represented by original constraints, right? Right, and uh, we have some property to verify, right? So let's say we
You mean this is the constraints on the input domain? Yeah.
these are the constraints of the output domain.
Output. That's what you want to verify that it is within this.
Yeah, yeah, yeah.
That's the
These are
property.
the let's say yeah, these are let's say real constraints, right?
Yeah,
When we
that's
do
the property you want to
approximation,
verify. Hmm.
that's the property we want to verify.
Okay.
When we do some abstraction, these constraints become something like very simple, but some over approximated,
Mm.
right? What we are saying, if negation of the property and the over approximated constraints is unset, means it is empty. If it is empty, then our property is verified, right? So its negation means its properties negation means the outer area, this outer area. And if its negation of the property and this over approximated constraints intersection is non-negative, it it means there exists some point which may violate the property, right? This is the area which is the violation of the property, outer area. right? On the other hand, if let's say our over approximated constraints are somehow uh, inside this property, right? And when we take the negation of property and the conjunction of this, and it become empty, it means the property is verified, because approximated constraint and intersection of the negation of the property. Negation of the property is nothing but all the area where the property can violate, right? If its negation is empty, it means the property is verified, right? So by using this over approximation, we can provide one way guarantee. It means we can provide, if the property is verified, we can say the original property is also verified, because this area is basic over approximated of the original area, right? While if we can't say this conjunction is empty, if we can't say this, then we cannot say anything, because this outer point, it may be because of extra noise added, or it may really be a counterexample, right? Is this point clear or not?
Yeah, I think I have stressed this point through
Okay,
various abstractions. So I think
okay, okay.
uh, they,
So
they
by using deep poly kind of abstraction, we can provide one way guarantee, right? We can only say it is verified, but we can't say, if suppose it failed to verify, we can't say there exists some counterexample, right? So to find out the counterexample, there are two ways. One, so I mean, let me discuss one way only, which I will discuss later in detail. But basically, what we do, we systematically choose the neuron or activation function and remove this abstraction from those one by one, right? If we remove this abstraction, then its over approximated consent area is reduced systematically, and there will be one point where this approximation become exact execution, or since it is reducing systematically, there will be one point where we can say this condition, right? Suppose there are 100 neurons, right? We have approximated all 100 neurons, and we are failed to verify the property. Let's say we choose systematically some 10 neurons on which we remove the approximation. So now we have only 90 neurons approximated, and if we check with this 90 neuron, we check this property with 90 neuron as approximation and 10 neuron as exact encoding. If we check this property,
yeah,
there
but
are
when you
chances it is verified.
for doing it exact encoding, you will have to then resort to either I mean like an MILP kind of an
Yes,
encoding,
yes,
right?
yes.
Yeah.
Yeah,
Okay. Yeah. Yeah.
yeah.
Yeah. Okay. Got it. Yes.
Right. So the complexity will increase a little bit because of these 10 neurons we are encoding in exact fashion, but it will still be bearable in comparison to if we encode the 100 neuron in the exact fashion. Right. So we'll see. I mean, in the reading paper also, we have provided a few paper in which basically you can see how the neuron are being chosen to reduce the approximation. And there are lots of work uh, after this deep poly kind of paper published, which are basically choosing the neuron to reduce the approximation to verify the property. Right. So before going into those paper, I'm going to introduce here PGD attack. So PGD attack is kind of one heuristics, which is
Yeah. Here I
basically,
want to pause and ask the
yeah,
class if you have any questions of the two
yeah,
key points
please.
that Afsal has made: the impact of over approximation and the refinement. Okay, that is it. Okay, if there are no, then please proceed.
Yeah, yeah. So PGT attack we discussed last time a little bit, but let us discuss with an example today. So suppose this is a neural network, and let's say it's a digit recognition. Digit recognition means it has 10 classes, 0, 1, 2, and 9. Right. We have input as an image. Right. Suppose x prime is the input variable, means it has x0 up to x. Can anybody tell? Suppose it's an MNIST classifier. Can anybody tell how many number of input of this classifier will be? Input means how many number of pixel for MNIST image. Suppose MNIST image is 2 dimension, right? We flatten into a single dimension and then give input to a neural network. So can anybody tell how many number of pixels in the MNIST image are? So there are 228 cross 28 number of pixels in the MNIST image, right? Something like this. And we basically flatten it. Now the number of pixels becomes 784. Right. So our input variable will be from 0 to 783. Right. And when we create precondition will condition on this input of the network. Precondition will be the conjunction of all point, sorry, 783, and each pixel can have a value. Let's say x represent of pixel I. It can have value x0 plus epsilon, and lower bound is xi. Sorry. Uh, sorry. Suppose the pixels are represented by z0 to z783, and this is the variable z. Right. Now each pixel can have a range. Let's say each pixel denoted by xi can have a range from zi plus epsilon. Sorry, from zi minus epsilon to zi plus epsilon. Right. So basically, each pixel can have some range. Let's say. Right. This is how each pixel has range. And suppose this original image, which is this one, x bar has a class of 4, right? So basically our post condition is saying for all I on the output 0 to 9, y4 should be greater than equal to or should be greater than yi, right? So what we are saying, within this range, whatever the range we are creating, the network classification should remain as 4. This is what the post condition is saying, right? Is this clear, pre and post condition or not?
Any questions here? I think, yeah, this they've seen. Yeah. So, and
Yeah,
one thing that I would remind is for the digit recognition system that you're recognizing, this is exactly how it'll, a property will look like. Okay. If you want to do
yeah,
some
yeah,
robustness properties and so on. Yeah. Mhm.
yeah. So basically we check the negation of the post condition, which is nothing but negation of the post condition will become disjunction, and we are saying y4 less than equal to yi, right? So we are saying if y4 or minus yi less than equal to 0, then our property is what to say, our property is violated, right? Or we can say ki if yi minus y4 is greater than equal to 0, which is basically we put on the other side, then our property is violated, right? So what PGD attack do for each I? Let's say right now we are considering only one I. Let's say we are considering y1 minus y4 is greater than equal to 0 or not. So it create a loss. Loss will be something like y1 minus y4, right? And it basically, let's say our input variable is z, right? So it creates the gradient of L with respect to the variable Z. Let's say there is some thing called delta L or something. I don't know how to present it correctly. Right. And uh, once we compute the gradient, now we need to update this we call Z is equal to Z minus this delta L. So basically, I don't know it is minus or plus. So basically, we are updating Z such that this should increase, not decrease. In general, we want to basically decrease the loss function, but here we want to increase it, right? So either we can take the negation of it and then try to decrease it, or we can just update our gradient method such that it increase this loss function, right? So idea here is if we increase it, there will be some point at which y1 will become higher than y4, right? This quantity will become positive, and that is the point we will note, and we basically throw it as a counterexample. Let's say it's zi plus 1, it's zi, right? Repetitively we are updating. So what is happening here is, let's say it's an input space, right? And there is some original image we had, right? We create some loss function, and by computing gradient, we are updating this image into a direction such that this loss is increased, right? So we are these are the updation, right? There will be one point where this may become positive, right? At each iteration we will check whether this expression become positive or not. If we find out some point where this expression become positive, then we'll call this as a counterexample, because this will be the point which is violating the property, right?
Yeah, but this
Right.
method assumes that, I mean, you will have to sample the input for certain, you have to
Yeah.
sample the input
So
space, no? Yeah.
yeah. So now, okay. Yeah, I'm coming to this point.
Okay.
Now we consider only for y1, right? We can consider one, two, and all the 9 cases.
Mhm.
Let's say we consider L1, L2, and L9, 9 loss function,
Mhm.
right? And we can correspondingly, we can sample the 9 point into the input,
Mm.
right? And we can basically run 9 PGD attack at one time in parallel and check. So it will like in parallel, each point will try to violate each property, right? Something like this, right? And if any one property is violated, then we will throw it as a counterexample. And for each one, we have to sample from the input space. Either we can sample or we can start from the original image. We can do this also.
Yeah, but the question I'm raising, Afzal,
Yeah,
is because this is a sample-based technique,
yeah.
it's really you. It is not as though you have verified it for all inputs, no, or have you? I mean,
No. So the thing is, it doesn't provide any guarantee.
correct. If there is, if you get an error, then that means
Yeah.
there's error. Yeah, yeah.
If we
Anyway,
get an error, then it is a error. If
yeah,
it failed to find the error, then
it
we
could
can't
still
say
be error.
anything.
Yeah. Okay.
But in practice, it is very, very useful. It is
Very.
very impactful, actually.
Mm.
Even in Alpha Beta Crown, which is the most state of the art, which is very good tool. In this, they basically call this PGD attack for every kind of problem. And if there is some counterexample, more than 95% cases, they will find out by using this technique. And it is
Mm.
very fast because it can accelerate on GPU and all.
Mm. Okay.
Yeah. So, like Dipoli crown kind of technique was providing from the verification side. If the property is verified, then they can say it is verified. Here, PGT attack kind of technique, it is providing another way. Like if they find the counterexample or error, then it is really a counterexample, right? And they use both technique in that first try to find out the counterexample, then they try to verify the property.
Yeah, like using over approximation. Yeah. Okay.
Yes, yes.
So
So
is
now,
this clear? Yeah, okay, class.
yeah,
I would. I don't know if we had. See, this is more like an. Yeah, I mean, I wanted to bring that thing up. Maybe we can. This is like more an under approximation. Okay, so in this, if it is, yeah. So the other one is it gives you guarantee, but if it fails,
yeah,
you don't know if it is real counterexample or not. Whereas here, if it gives a counterexample, it is a real error. But if it does not, then you don't know. I mean, maybe you have to increase your sample size or something. So this kind of a technique, I would classify it as using under approximation, because you're not classifying the behavior completely. Okay. uh,
yes, yeah,
yeah.
yeah.
Any
So
questions
now,
here? You have to ask
yeah,
questions. uh, you know we will
yeah. If you have any question, please ask.
Yeah, I mean, even if you don't right now, what I've asked is because the class, you're amazingly quiet. Okay, either because you're shy or for whatever. I've asked, Afzal to give you some questions, a set of questions, for you to work on, to
Yeah,
ensure that you force yourself to understand this thing. And of course, we cannot, I mean, that's force you to do that. But and at least from our side, we're going to do that. And if you are have any questions there, you can always come back and then do it. So that kind of a
yeah,
voluntary exercise, that's not going to be an official assignment, but it's just a voluntary exercise that I suggest that you should be doing it, so that if you have that, if an opportunity for you to force yourself to understand. And since the final exam will have some questions on the content of the lectures that Afzal has given, in order to help you to force yourself to understand, we are doing that extra work. Beyond that, it is up to you to put in the effort to assign it, or you can do whatever you want. Okay. Okay. Yeah.
yeah,
It's up to you. Okay. You can move ahead. Yeah.
yeah. So now we are moving some other kind of extraction which is used in alpha beta ground. So these are the deep polys abstraction which we have seen just before, right? These are the two possibilities for deep poly. Can anybody guess? Is there any other possibilities for lower expression? Can anybody guess it? Right. Right now we have two lower expression. One is this. One is this, and we are dynamically choosing in deep poly. Right. Either one. Is there any other possibilities of lower expression?
I mean, even before that, when Afzal
Yeah.
asks that this is it's a lower bound, is what you're saying, okay, right? Lower
Yeah.
bound
Yeah.
expressions.
Yeah.
Can anyone answer why do you understand why it is indeed a lower bound expression? I mean, Afzal asked if there is another candidate, but I'm asking you even a more fundamental question. I mean, I'll assume if you stay quiet, then it means that you don't understand. Okay. If you're afraid to say no, or coy to say no, that's okay. Okay.
Yeah.
But if somebody is courageous enough to say yes or no, you know, or Shall I assume that maybe you just signed in and you just left the meeting? They're also quiet. Can I ask people to turn their video on to see if you're really there? So your lack of answer is it that you don't understand, or you understand? You don't understand but afraid to ask? What is it?
Yeah, please ask if you have any doubt or not able to understand. You can directly ask. There is no. mm,
Kush at least is saying he understands.
Yeah.
Okay. So then, can you, yeah. So now you could go ahead. Okay. And I don't know
Yeah.
what other people think, because they refuse to speak. So then we cannot help those kind of people. So,
Yeah.
yeah, anybody wants to answer Afzal's question? If there is any other candidate for what could be
Yeah.
possible lower bound, when he draws this area, it means that the lower bound could be anywhere there. Okay, it may not
Yeah.
be the precise lower bound, but it will be
Yes.
something which is more permissive. Okay.
Yeah.
Yeah.
So lower bound is something which basically on the actual value is greater than something. For example, here, right? Y is always greater than equal to 0. Y is always greater than equal to 0. I'm sorry again. Yeah, this y is always greater than equal to 0. So that's why this expression y is greater than equal to 0 is become one kind of lower expression,
Yeah.
right? And similarly, y is greater than equal to x is another kind of expression, because suppose x can be negative, but y will always be greater than equal to 0, right? So from here we can say y is greater than equal to 0 and y is greater than equal to x, right? So this is bounding from the lower side. This is bounding the y, right? Because suppose x is positive, then because of this condition, y will always be greater than equal to x. And if x is negative, then since y is greater than equal to 0, so it is something like positive number is greater than equal to some negative number, which is always hold, right? So that's why these two are the lower bound. Now the question is there any other possibilities, or is there any other candidate which basically bound it from which basically provide the lower bound expression, right? Is there any other line of the lower expression?
Which could be, I mean, not necessarily better than both, but in some cases
Yes.
it could be better. Huh?
Yeah. Yeah.
Mm.
If I am saying y is greater than equal to -1, this is also one kind of approximation, right?
Mhm.
It is also one kind of lower bound, although it is not tight bound, it is not precise bound, but it is also one kind of approximation,
Yeah, but that you
right?
would even, yeah, yeah, but that is not
That is
desirable.
not
Yeah,
yeah.
have y greater than or equal to 0 is this
Yeah.
thing. Yeah. Mm.
So similarly, I'm asking, is there any other line which is basically similar to the Polish over expression? Okay, so let me put one line, and this is something like this. Uh, okay, it is something like this. For some slope, right? I'm not sure what is the slope, but let's say for some slope between 0 to 1, this is one kind of approximation, right? Right. Are people agree with me?
Mm.
Right. For some alpha, it could be something like this, right? And this. So this
Yeah,
is
so there
this
could be
value.
other things like, okay, the one that you've showed on the right is also one such with a different slope, correct? Yeah.
Yes, with different slope.
This
And
is a different
between,
slope that you have. Yeah.
yeah, between 0 to 1, there will be infinity number of slope. So there will be
Slopes.
infinity number of lower expression, right?
Mm. Is that clear, class? Okay, this is a clever way of doing it. Okay. So you
Yeah,
could kind of tilt that lower line, okay,
yeah,
in different ways. Is that, yeah, very good. Yeah. Is that
right.
clear? I hope it's clear to them. Yes.
Yeah. So
Yeah.
basically,
Very
Dipoli was
good.
saying
Mm.
कि we will Dipoli was saying कि we will choose either y greater than equal to 0,
Mm.
either y greater than equal to 0 or y greater than equal to x, right? Now alpha crown people, this is the basically alpha crown approximation. They were saying why choosing out of these two? There are
Mm.
infinite number of possibilities, and we can choose the one which basically minimizing the loss error, so approximation error,
Mm.
right? So what they are saying, let us keep the expression, lower expression is this: y is greater than equal to alpha into x, and alpha is a variable having range between 0 to 1,
Mm.
right? So it contains both. When alpha is 0, then it is containing y greater than equal to 0. When alpha is 1, then it is saying y greater than equal to x. So it basically contains the Dipolis expression approximation,
Mm.
but it basically provide more choice, right? It is saying choose the one alpha which minimizing the area, right?
Mm.
And not minimizing the one particular area. Yeah, not minimizing the area of one particular node. See, why we are doing this approximation? We want to basically verify some property, right? So what alpha crown people are saying, let's say our property is to verify that y4 should be greater than y1, right? So they are creating an expression which is saying the output is, let's say, y4 minus y1 greater than 0, right? So they are saying choose the alpha which minimize this as much as possible. No, sorry. So choose the alpha which basically minimize y1 minus y4 as much as possible,
Mm.
right? So basically alpha, we all sure कि alpha between 0 to 1 ensure this is some over approximation. Now choose the alpha such that this expression has the minimum value or this expression has the maximum value.
Yeah, but this expression y4 minus y1, that is the property, correct? That is
That is
coming.
the property.
So this is with respect to the property you try to, so you increase, enhancing the precision. Uh,
Exactly.
yeah, you're choosing the alpha such that it enhances the precision of giving a correct answer. Okay, for that
Yes.
particular property.
Yeah.
Right.
And the second thing is,
Mm.
suppose these are our values. We For each one we have alpha 1, alpha 2, alpha 3, right? After that there is some affine layer. So all these expressions are connected, right? Alpha 1 and whatever is corresponding, let's say x1 and alpha 2, x2, alpha 3, x3 somehow connected, right? Plus, minus, whatever. So when we minimize on the complete network, not with respect to particular neuron, but to the complete network. So it is basically somehow joint optimization. So it might be the case if we see each neuron, each activation individually, it might be the case some approximation is basically tight with respect to some particular neuron, right? But not with respect to the overall network. But when we are minimizing here, we are minimizing with respect to complete network, right? and it basically ensure globally alpha all alphas are producing the approximation which minimize the final property loss, not the one particular ReLU loss, but the final property loss. Is this point clear or not?
Yeah, but what was not clear to me, Afzal, I
Yeah,
mean, maybe, yeah,
yeah,
maybe they have other more questions too, but I'll ask one question.
yeah,
So you're introducing one alpha, this parameter, okay,
yes,
that it has to pick to kind of optimize the
yeah,
precision. For each ReLU, you will associate one parameter for alpha one. Is
yes,
that the idea?
yes, yeah, yeah, yeah,
And then this expression that you wrote there, the
yeah.
alpha is the linear layer, is it? I mean, is that or
Yeah,
what?
it's a linear layer. It is some combination of previous
Okay.
activation function.
Then you
Yeah,
will have this will be input to the ReLU, okay,
yeah,
correct?
yeah, yeah.
Uh, and you would then, yeah, pick alpha 1, alpha 2, multi-dimensional optimization. Okay, I mean,
Exactly. So before Dipoli and Crown was doing, they were treating each ReLU activation independently, right,
mm,
and minimizing independently.
mm,
Now they are saying they are improving two things. One is either choosing either of the two abstraction, choose the one out of infinite number of approximation.
mm,
Second thing is the choosing criteria should not be independently, but it is jointly with respect to the property,
mm, mm,
right?
mm.
And what these people are doing, right? Suppose this is the network,
When you say these people means the beta crown.
alpha crown
Alpha
people.
beta. Okay.
Yeah,
Mm.
this is the alpha crown people basically.
Okay. Mm.
Yeah, what these people are doing, they have one property, let's say y4 minus y1, right? In the network, they have multiple alphas, right? Alpha 1, alpha 2, and so on, right? They are creating again, they are creating the loss function, this expression as a loss function, and they are computing delta L with respect to delta alpha,
Mm.
gradient with respect to alpha, and then they are updating the alpha. When they are updating the alpha, it will be something like this: alpha I plus 1 is equal to alpha I plus or minus whatever we are minimizing or maximizing, depend on it, right? And the gradient we are computing,
Mm.
right? So they are initializing alpha any value between 0 or 1, any value, and then they are keep optimizing it. So the third benefit of this approach is they can stop anywhere, right?
Mm.
Their approach will always be over approximated. They can stop anywhere because alpha is always between 0 and 1, right? Let's say if we
So
were
it
getting,
doesn't have to be run to convergence. You can actually stop at any time.
we can stop anyone anywhere because alpha I plus 1 will always be between 0 and 1, and which ensure the over approximation,
Mm.
right?
Okay.
Yeah, so in summary, they have one is choosing lower bound expression out of infinity choices, right? And minimizing abstraction error globally. And the third point is they can stop anyway in any iteration.
Yeah.
So now, can people think, is there any, so this is what alpha crown people are doing, right? And they have basically accelerated this approach again, since this is based on the gradient, computing gradient and all, they have implemented it into PyTorch and accelerating on GPU. So it is very, very fast.
Mm.
Is there any other way? Right now they are optimizing alpha by using gradient. Is there any other way to optimize alpha? Can people guess?
Can you encode it? I mean, well, I'll let other people answer it first. Guys who are there, Kush, Pranita,
Yeah,
two of them have dropped out. Okay. One, two, three, four. There are only four. Actually, there are only three people left. Okay.
yeah. So
Uh, yeah. I mean, I guess. Let me see. Is there a Kush is here? Yeah, yeah. I know. I can see Kush, and right now there are only two people here that are here. Maybe Raguraj is here. I don't know. Yeah, Raguraj is here. Uh, yeah, I guess they don't have. I mean, I don't know. Can you repeat the question? Is
so
what
question is, we are optimizing it. Uh, yeah. So
by making the gradient on alpha? So
yeah,
your question is if there is.
optimizing property loss. When I'm saying property loss, it means loss with respect to y4, y1 kind of thing.
Hmm.
Loss with respect to alphas using gradient based algorithm. Right. Either gradient descent or gradient ascent algorithm. Right. Now, my question is, which is also exercise, is what are the other ways to optimize this property loss?
By other ways, you mean other than using gradient descent
Yes,
kind?
yes, yes,
Huh?
yes. Yeah.
Anyone wants to take a crack? If not, I have a thing. I mean, is it possible to, instead of using gradient descent, can you do some kind of a branch and bound technique or some, I mean, can it be expressed as a real optimization problem, either with
Yes, I mean,
LP or
yeah, we
something?
can use LP solver here, right?
Correct. Yeah. Mm, mm.
Right. So the upper expression will be same. What is y less than equal to mx plus c, whatever you compute. The lower expression will be y greater than equal to alpha into x, and we can say alpha has the bound between 0 and 1. Sorry,
Mhm.
0 and 1. Right. So we have all the linear constraint, and finally we have some optimization function, which is, let's say, with
Yeah.
respect
The
our,
property, the
yeah,
property
property
is
here.
the objective function, correct? Yeah.
Yes, yes. Right. And this is what basically in the exercise we want to do, using LP solvers.
Mm.
Yeah.
Yeah,
Let
it
me also
has to
highlight on
find
this.
the value, the best, the optimal value for alpha with
Yeah.
the property correctness, precision of the property violation correctness as the objective function, correct?
Yes.
Mm. Yeah, this is actually an LP problem because alpha is any real value between 0 and 1. So it can be expressed as
Yes.
LP.
So we have seen the dipole example, right? Which is basically here. This one example, right?
Mm,
Now the exercise will be, can we, so this dipole means they are choosing either of the two approximation, right? We want to run same example, but instead of choosing after of those two, we want to choose, we want to keep this as a variable alpha, and we do the final optimization and find out what is the value of alpha. Basically, what is the lower expression of each neuron,
mm.
right? And just compare whatever the expression we were getting by using deep poly, which is basically same as written here, and the expression we are getting by using alpha crown.
Yeah, but when you say it has to be done, you have to make as many LP calls, one for every. You have to kind of, how do you do it? I mean, because there are multiple nodes, how will
Yeah,
you still have to compute these different alphas for different things simultaneously, no? Or you do
yeah,
this combination of alpha 1, alpha 2, and have
yeah.
as
So
much.
basically, when we have encoded this lower expression in terms of alpha, and we have optimized the property loss, then
Mm,
finally we will get some
mm.
optimization value of this, as well as the value of each variable, which also include the alpha 1, alpha 2, alpha 3.
Yeah, so the LP, yeah, so you'll have to have as many alphas as well, no? And then you,
Yes, yes.
yeah.
So value of all alpha will be basically
The
LP solver will be all values at once.
Yeah, so it'll give you the output of that. But when you
Yeah.
say you want them to do the exercise,
Yes.
uh, obviously for you could they could probably use the same example that you have
Yeah,
shown, the
yeah. Yeah,
example.
same example.
That then they'll have to run an LP solver, right? In order
Yeah.
to even for the small example, it'll be hard to do by hand.
Yeah,
Uh,
yeah. They will run LP solver, definitely.
mm, okay.
I would suggest run the Groby LP solver,
Mm,
because, and if you are facing any problem, just let me know, because I use it, and this is very simple to use.
yeah.
Yeah.
Okay, now I think what is your plan? I mean, what I suggest. Okay, you can take as much. Okay, I don't know. People have left because it's a Friday. Maybe
Yeah.
that's why some
Yeah.
people left. But what I suggest is getting close to 6 here. Um,
Yeah. So
if you,
basically, the remaining topic, the beta crown, which is very simple. I'll just explain in 2 3 minutes,
uh,
and using of alpha beta crown, I'll explain. So I can finish in next 10 minutes.
Yeah, why don't you do that? And
Yeah.
once we have this exercise problem and then we publish it, if I may
Yeah.
request you to just indulge you to come back next Tuesday to answer any questions that they may have. Okay, because I'm just to think. Will that be okay with you? Yeah.
Yeah. Sure.
Okay. Yeah,
Yeah.
please go ahead. I have the
Yeah.
recording. I'll kind of coax them to watch uh,
Yeah.
the recording,
So
and we'll have the exercises. Hopefully they would have had some time to attempt it, and then we'll give them an opportunity to ask any questions on Tuesday. Yeah. Okay.
yeah. So what is beta crown? I mean, this alpha crown is about approximation, right? And since I mean, the alpha crown is also an over approximation, then it is possible that they fail to verify the property, right? What beta crown is, it choose the neuron and split it. For example, they have some algorithm by which they are choosing the neuron to remove the approximation, and they split that neuron. So when I say split, it means they are saying, so they are choosing this neuron, they are saying in one case uh, x is less than equal to 0 and y is equal to 0. This is, and the other case is x is greater than 0 and y is equal to x, right? So they are creating for each neuron
The
that,
active and inactive cases, those are the two.
yeah. And basically if they are choosing, let's say, some 10 neuron, or let's say they are choosing one neuron, then they will create two sub problems, one for active, one for uh, inactive case, and solve them in parallel. But they are not choosing just one neuron, they are choosing in bulk, right? 8, 10, 12 number of neurons, and then they are creating all sub problems. For example, if there are 10 number of neurons, then there will be 2 to the power 10 number of sub problems, and
Mm.
they are solving all in parallel. And the beauty of this beta crown is this, all this splitting and solving sub problems in parallel. They are doing all these basically stuff in PyTorch, and again they have accelerated this method also on top of GPU, and they are performing very well.
Yeah, but I
This
have
is
one
the alpha
question
beta
here.
ground. Yeah, yeah,
Now, if you split it, see, unlike in, okay, yeah, I mean, there are only two people. Okay, maybe you'll have to repeat it next time because there are
mm,
only two people left. But I'll pose the question anyway. Okay, and
mm,
then now, but if you see in Reluplex, which also does the splitting. So if
yes,
the
yes,
original query is like a SAT query, then any one of the branches, if they satisfy, it gets satisfied, then you're done. If it is an
yes,
unsatisfied query, all of them will have to be met. Now,
yes,
here, when you split into active and inactive cases,
yeah,
what is the result? How do they put together the result? Look, if they have, say, if say there is only one node, so in the active case, you solve it, and the
yeah,
result of solving it gives you some optimal alpha, I presume, for the active case, and some optimal value for the inactive case, correct?
yes, yes.
So, but what is the, which is the best? How do you put them together?
So, so
Mm,
they are basically on each sub problem, they are trying to verify the problem, right? If there was creating two sub problems,
mm.
problem 1 and problem 2, they are trying to verify each sub problem, and if they both are verified, then they can say the problem is verified. If they
So
fail to
it has to
verify,
be verified in
yeah,
both cases. Yes.
yeah, but the
Yeah.
thing is, they are not all the Reluplex and all method, they were doing either checking these sub problem one by one,
Mm.
or they are basically doing some kind of parallelization on
Yeah. Yeah.
CPU.
That part I understand. Okay.
Yeah, but here the plus point is they are accelerating it on GPU
Mm, mm, mm.
by implementing in
Yeah,
PyTorch.
but that could be done even for Reluplex, no? Okay. So
Uh, I mean, I don't know, but till now they are not able to do it
yeah.
uh,
Okay.
even for Marabou.
Okay.
I mean, the plus point of alpha beta crown people is that they are all techniques like crown, alpha crown, beta crown, alpha beta crown. They all basically accelerating on GPU.
Okay.
Yeah. So now, yeah, let me quickly introduce the tool alpha beta crown, if you allow me now. I already have set up the stuff.
Ah, can you, since there are only two people left, okay, and do you
Yeah.
want to finish it off this part now, or do you want to, if since you've decided that you will be doing one more class, do you want to give the
Uh,
demo next time? Hmm?
so the thing is, I mean, it take hardly 10 to 12 minutes maximum,
Okay, so why don't you?
and
I'm saying
I
that you may
don't
have to
think,
repeat it because there are only two people left. Okay,
yeah.
on
So I
the
can do, but it won't be 1 hour class in that case. I will take in the next
yeah,
class.
for
I
half an hour.
maybe,
Uh,
sorry, for
half an
half
hour.
an hour we can keep it for
Yeah, why
half an
don't
hour.
you? Okay, there is Raguraj and Kush.
Yeah,
You will take another 10 minutes, say, or 15 minutes. Are you willing to stay, Raguraj and Kush? Yes, so they're willing to stay. So since it's being recorded, why don't you do it? And we'll assume
yeah,
that you'll have give us half an hour to answer any questions that they may have next time. Yeah. Okay. Fine.
yeah, sure.
Yeah.
So this alpha beta crown,
Yeah. What you just now described was what you call as beta crown, correct? Yeah.
yeah, and
Okay.
the technique like we have discussed deep poly, which is also called as crown. We have
Mm,
discussed crown, alpha crown, and beta crown,
mm,
and PGT attack also.
mm,
And alpha beta crown is basically a tool which is basically put all technique together to solve to verify a neural network. And not only this thing, they also have some other technique like here are the paper they have put on their GitHub repository.
mm,
They have crown, they have one library, they have alpha crown, beta crown, they have general branch and bound, which is
mm,
basically if they fail to verify the property, they have to split on the neuron. So
mm,
beta crown is also same, but they have different technique to select the neurons. They have general cutting plan, branch and bound attack,
mm.
and many more. MIP we have discussed, mixed integer programming encoding. We already have discussed. So the other paper, I mean, it depends on the people interest. If they want, they can read the paper
So
from
all
here.
of these things, the branch and bound, etc., they're all optimizing on the alpha, is it? Yeah.
Exactly, yeah. They are basically on top of
Different methods to optimize
alpha
alpha, you
crown.
would say. Yeah.
Yes, yes, yes.
Okay.
Yeah. So its installation is very simple. I mean,
Mm,
you just need to install Anaconda and create the Anaconda environment
mm,
by using this command.
mm,
First, of course, you have to clone this GitHub repository.
mm,
Then you have to create Anaconda environment. Then you just activate this environment.
mm,
Conda activate and whatever the environment you have created. Now, to run this tool, you may require something called yeah. To run this tool, you may require some MILP. MILP. Yeah, you may require some license of MILP solver. For example,
mm,
AirSen, unless you use MIP-based verification algorithm, a Groby license is not needed. But in general, for most of the benchmark, they required MILP solvers. So
mm,
I would suggest to run basically to install the Groby license. It
mm,
is very easy to install the Groby license. You just go on to uh, Groby solver optimize so Groby solver website, and you just have to create your account by using your academic email ID,
mm.
and they are very simple steps. You can just take the academic license from there.
So you can freely get the academic license for Gurobi. Yeah. Okay.
Yeah, and after login, immediately you can get a free license. There is
Mm,
no wait or something. So
okay.
once you install the Groby license
Mm,
and you have cloned this alpha beta crown, and
mm,
this is how the alpha beta crown directly look like
okay.
directory, right?
Mm,
Now there is some benchmarks, and I will introduce VNComp benchmarks. I'm going VNComp 2022,
mm,
but every year they have benchmarks, and let's say okay, let's say for 21, yeah, let's say for 21 there are some benchmarks. In the benchmarks folder there are lots of benchmarks: ACAS, XU, CFAR 10, CFAR 200, Iran, different name.
So these are
Similar,
DNN neural network benchmarks with some
yes,
property
yes,
that they're trying to verify. Huh?
yeah.
Okay.
For example, MNIST property we have something like this. So I already have downloaded these benchmarks, which I will
Mm.
show you.
Mm.
Uh, okay, networks all. We already have these benchmarks I have downloaded. So these benchmarks have two, each benchmark has two directory. One is ONNX, which is basically network. One is property file.
Mm.
ONNX is nothing but the neural network. This kind of neural network. They have three network, for example. The property has something like this, which I wanted to show you, which is VNN leaf, which is the property. Let's say I am opening the property 0.005, right? So what this property means,
Mm.
let me explain it. So they are saying this is the property created for image 4.
This looks very much like SMT lib format, huh?
Exactly, yeah, yeah.
Mm.
So
Mm.
X is representing the input variable. So for MNIST, remember we have 784 number of input variable, right? So they
Mm.
have started from 0, x0, x1, and
Mm.
up to, yeah, up to 783. They are
Mm.
declaring the input variable.
Mm.
Similarly, output variable they are declaring y0 to y9.
Mm.
Based on each pixel value, they are basically creating the lower and upper bound. For example, here the
Mm.
lower bound is 0, upper bound is 0.05,
Mm.
right? Once they have created, so this is nothing but precondition.
Mm.
Then this is the negation of the post condition. So
Mm.
this was the image of image of class 4. So they were
Mm.
checking, or
Mm.
y0 greater than equal to y4, or y1 greater than equal to y4, or y2 greater than equal to y4, and so on
Mm. Mm.
up to y9. So that's
Mm.
all the VNLE property have.
Okay, okay.
Once we have these two
So this
property,
seems like this looks like this particular benchmark is actually a digit recognition.
yes, yes,
Yeah.
digit recognition.
Mm.
And we can go through the benchmarks also. There's some generate random instances file.
Mm.
Basically, for each benchmark, they have explained how they have generated the benchmarks. The
Mm.
code and all will also is also available.
Mm.
Once we got the network and the property,
Mm.
we verify by using neural network, right? So I explain how. So this is something called this is the alpha beta crown directory, right? In the directory there is something called complete verifier. Inside
Mm.
the complete verifier, this is something called abcrown.py. This is the main file.
Where? I don't see AB crown. Where do you see that?
This one.
Huh? No, I don't see it. I mean, it's too small.
Oh, is it too small?
Or you're not showing the full thing. Okay, there are things that are hidden.
Is it?
Yeah, I mean, I think I don't see. I see Python. The last line that I see is just Python. Complete verifier. Now I see. Okay. Okay. It was too
Yeah,
small. Yeah.
you can see, right?
Yeah. Yes. Yes. So you're invoking abcrown.py. That is
Yeah,
the
yeah,
tool.
yeah. So
You have
we
to,
can basically what we can check the abcrown.2. There is help option.
yeah, but when you type something, it goes below. So you have to push it up. Yeah. Okay. Mm.
Yeah, there is some help option. They have explained all kind of parameter argument they are taking and their description. There are more than 100
So this is, you
kind of
get this
argument.
one by typing some help or something like that, is it?
Yes. Hyphen H.
Hyphen H. Okay. So
Yeah.
that gives all the different knobs, okay, different kind of options that you can have. Uh,
Yes.
and all the ones that you listed, the different methods for optimization is one can try, is it? Hmm?
Yeah.
Mm.
So this is how we can run alpha beta crown, right? In the Python, in the complete verified, this is abcrown.py, which is the main
Yeah,
file.
you have to go up. You keep, because the bottom lines are not visible. Okay. If
This
you're,
line you can see, right?
yeah, but that is no, not fully visible. Okay.
Oh,
Yeah, but scroll up, please.
the
Scroll up. Okay. Because you're not, you see, because you have not uh, gone full screen, and that's why there's this bar in your thing.
Okay, just wait.
You have to scroll up. That's all. Yeah, now that's right.
Now you can see, is it?
Yes, yes, yeah.
Okay, okay. So this is abcrown.py is main file. This
Mm,
one. This is the main file, right?
mm,
Then there is one parameter config. Config means for each kind of benchmark, let's say for MNIST benchmark, they have different type of argument they are setting, right? For example, for MNIST in the complete verifier, this is example configs in which VNN count 22 and MNIST.fc.yaml.
yeah, what is this config?
Yeah, this config, let me just open and show you.
You have to create a config file before you can run, is it? Hmm?
They are already existing in the tool.
Yeah, but
So inside
what
this,
is its purpose? Why do you need a
yeah,
config?
yeah, I'm just telling. So this config is nothing but telling some kind of information to the network, like what is the input shape of the network
Uh,
and what kind of solver we are using, their batch size, they are using beta crown, they are
oh,
using mixed
oh, so
integer.
important information about the input shape and
Yes,
uh,
yes,
what is the
KGP attack
start
and
and
all.
end? What is start and end? 3090.
So basically, what they are doing, if we see this benchmarks, na, they have something called uh, VI. They have something called install instances.csv file, which
Mm,
contain all the benchmark list. So
mm,
when we are saying this start,
mm.
when we are saying start 30 and 90 means start at benchmark number 30 and at benchmark number 90.
Okay, okay. So it kind of runs on multiple benchmarks. Therefore,
Yeah,
that is what you have to specify using start and thing.
yeah.
Okay.
But if we intentionally put our particular property file and network, then
Mm,
this start and end doesn't matter.
mm,
Then this
mm.
thing doesn't matter.
Okay.
Right.
So is there a README file in that directory that explains some of these things, or no?
So like I showed this dot helper file, na, they
Uh,
have all the information about it.
mm, mm. I guess they'll have to experiment a little bit in order to really
Yeah,
get
yeah.
the thing.
Yeah.
Okay.
So once we have this configuration file, right,
Mm,
then we say on which device we want to run. Device can be either CUDA or CPU. CUDA means we can run it on GPU if it is available. Otherwise,
mm.
you can set it as CPU. Then we give ONNX path. ONNX is nothing but the network path. They are considering the network extension as ONNX file. So network can be at many type of network, right? PyTorch network, TensorFlow network, and all.
I don't understand. What is the network?
Network type, the saved network, which is the trend network, which is already saved, they can be of any type. They can be of TensorFlow type, they can be of PyTorch kind of type, and so on.
The input DNN network format. Huh?
Yes, yes. So VNN competition, I mean, this verification community standardize the input as ONNX format.
Oh, I see. I see. Mm,
Yeah. And then we provide the VNN path, means the
mm,
property file path,
mm,
right? Which we already have seen. Then we can provide timeout.
mm.
Then we can run it,
Okay.
right? And here it is saying set means they found the counter example.
Mm.
If we want to print the counter example, we can also give one parameter show. I forgot this parameter actually. Let me just check. Yeah, this one.
Oh, adversarial example. That's what they
Yes,
mean.
yes. So it will show the values of adversarial example.
Mm, mm,
Like this is the pixel value of input,
mm,
right? And let's say if you want to prove some other property, let's say this property, this is basically verified property I wanted to set. So it is saying it is the result is verified,
Mm,
and it got verified by using the crown itself.
mm.
No need to go further into alpha crown or
No,
any other
even
thing.
without us specifying, it kind of is a portfolio kind of a thing. It tries its own. First, it tries MILP, then Crown, or something like that, or you have to specify which sub to
Basically,
that
yeah,
lucky.
it is in the config file we can set.
Okay, okay.
Like they have set the solvers, make, branch and bound, attack,
Mm, mm. Attack is this PGD.
PGD. Yeah,
Okay, okay. Yes, there's a lot to learn.
yeah,
So that's good that you have introduced. So they'll have to, I will try to encourage them to actually, I'll have Lucky also to help install it here. We have a compute server here. If you can install it on that, whether that is a GPU server or not, I don't know. Okay.
yeah,
Now, there are two options. One is I can install it, with the help of Lucky, who's the TA,
yeah.
to install it on a compute server for which we can give the class the access, or they can install it on their laptop. But that is not going to be possible, isn't it? Okay, to
No,
have them
for
installed in their individual laptops. Is it
no,
possible?
the thing is for MNIST kind of network, digit recognition kind of benchmarks,
Hmm.
laptop is sufficient. For bigger benchmarks, let's say ImageNet or C400 kind of benchmarks,
Hmm.
laptop won't be enough.
Hmm.
So for digit recognition benchmark, laptop, I mean, AlphaBetaCrown can run on a laptop. There won't be an issue.
I see. I see. Okay.
Yeah,
Okay, it's getting six. It's 6:15, 6:18. So I think we'll have to stop here. Any loose ends, I will, talk to you. Okay, and I will list some of the loose ends that I want you to tie. Okay, and also ask the class about specifically with respect to installation and so on, because they will have to use as part of their exercise. So if there is something like that, so I'd appreciate if you could spend a half an hour or so next time, yeah, on Tuesday. And I will make
sure,
sure that
sure.
people will attend that, so that they will get the thing, yeah. Okay.
Yeah,
And one
sure.
other thing, of course, we'll have to work towards kind of making that exercise and then publishing it, so that they will do on their own, yeah.
Sure.
Okay. Thank you very much,
So
Abzo.
next class will be mostly about question answer kind of
Question
thing.
answers, and specifically about installation and running it. Okay, those two things. Question answers
Definitely.
generally about the thing, because we're going to prepare the exercise and then publish it. Whether any general question that they may have based on the lectures, and if they have attempted those exercises, they may have specific questions. That is, if depending upon how much thing. But I will insist that they'll have to should have attempted at installing it, and then have any questions about installation, etc. But even if they don't have it, Lucky will be. I'll make Lucky the TA to install it, so that he will be on top of it. Okay, even if so that he will uh, 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 you know have learned from you. Okay, and I view the thing, and then he'll be able to be guide them. Okay, later
Yeah,
on.
sure, sure. So for one, if someone want, he can send email to me. I
That's right.
will
Yeah.
assist
Okay. Then
him.
you could do that. That's yeah.
Yeah,
So I'm
because
very
in class, like I try to help, but installation fixing installation issue may sometimes take too much time.
yeah.
And
No, I think that's where, rather
yeah,
than see, I can have them reach out to you directly, but there are 10 people in the class, and if all of them individually are reaching out to you, then it'll be it'll be more efficient if, even if you can spend half an hour in an extra tutorial on a certain day, we can get all of them. That's better. Okay. So it'll be better, more efficient for you to do, rather than doing it. After that, they can do it individually also. So that I will do, and I'll certainly be in touch with you to figure
Sure.
out what the best way to do it is. Do that. So yeah.
Sure, sure,
Okay.
sure. And the last thing is right now in TCH, the internship hiring is going on. If anyone is interested to do
Yeah, I think
internship
what we should do
for,
is, since we have agreed, is there a deadline for that?
there is no hard deadline, but this is the time to apply.
Okay,
Now
fine
nowadays
then.
we are getting
I
lots
think
of
what we
drive
should do
from
is,
different colleges.
I know you already have
No,
half an hour. If you could announce it when there'll be more people on the thing.
yeah,
Something about your group, a little bit about your group, and what is it, what the kinds of things that you do, etc. Then that'll be better. Okay, and
yeah, sure,
I encourage you to spend 5 minutes canvassing
sure,
in
sure.
class. Yeah. Okay.
Yeah, sure. Okay.
Okay. Absolutely.
Yeah.
Thank
Thank
you.
you.
Yeah. Thank you very much, Ragraj and Kush, for staying through the end. Thank you.